Hi everyone, as Ellie said, I'm Paul Jolly and I'm co-founder of an early stage company called ModelLogic, and we're looking to build a financial modeling platform ultimately to replace Excel, but that's totally dull, so I'm not talking about that thankfully. Instead, I'm talking, as Ellie said, about using Go, which is normally a back-end language to build front-end applications. And Ellie gave me the title for today's talk as well, which is fantastic. So what we're going to look at is, as I said, building a front-end application in Go using React. As Claudia was alluding at the beginning, React is, to my mind, a really good pattern for building front-end applications. And for me, Go is a really good language for just writing any code. It doesn't matter whether it's front-end or back-end. So this represents the meeting of the two, if you like. Just so I can see how many people have actually used Go before, just even writing a small amount of code. So maybe 30%-ish. Okay, great. I'm not going to go, it's not going to be a deep dive into the language. I include a number of links at the end of the talk for you to go and look to learn more about Go, the language itself. So I'm not here to actually convert everybody to using Go, to stop using JavaScript and just start doing everything in Go. It's really just to present an alternative. As Claudia said, really present an alternative tool. And if the Go and React combination works for you for whatever reason, then use that tool if it's the best for the job. So as I said, we're going to have a brief overview of the language today. We're going to write a browser-based interactive front-end app in Go. We're going to use the wrapper that I've created around Facebook's React library. We're going to use a code generation tool called GoGenerate, which is part of the Go package itself, the distributed Go package. We're going to see some of the benefits of writing front-end apps in Go and end up with happy front-end Gophers. And the Gopher is the mascot for the Go language. And this is a Gopher that's been rather dressed up down at the bottom. We'll see some more dressed up Gophers later on. So let's just quickly start with some definitions for the purposes of this talk. Everybody in this room is almost certainly a more experienced front-end developer than I am. So I will defer to your better experience and understanding of these things. So these are just my definitions for today. So by front-end, I'm talking about a browser or equivalent on a client device. So that does include things like Electron-based apps. Rendering of HTML and CSS for the actual visual part of the application. The back end could be non-existent, local, remote, doesn't matter. I'm not focusing on that for today. Interactive, again, every page, HTML page, is effectively interactive if you consider clicking on a link as being some sort of interactivity. But for today, I'm talking about intra-page responsiveness and the visual changes that come in response to things like keyboard events or mouse clicks, whatever they may be. May or may not involve back-end calls. As I said, we're not going to focus on that today. And by an app, what are we talking about? An HTML page or pages that are themselves interactive. Could be a single page or multiple pages. So why is any of this important? Again, I'm sort of preaching to the converted here because everybody here is sort of on that bandwagon already. Browser is an extremely good cross-platform way of building front-end applications. Billions of devices out there, almost zero cost to adoption from that perspective. So again, there should therefore be a low cost from a development perspective as well. So this, the presentation you're looking at here is actually an HTML web page that's being served from a web server that is a Go tool called Present. And given that it's HTML, you can actually inline iframes within it as well. And so some of the examples of interactive front-end apps we're going to look at here are actually Go React applications. They're very, very simple, but just to give you a bit of a flavor of what we're looking at today. So if I can drive my mouse over here. This is a very, very simple one. Clearly, this drop-down at the top here is there's some sort of state associated with this drop-down here, which is then driving the lower part of the panel here. This button, very, very basic. Nothing particularly exciting about this page here. This is an example that you'll recognize potentially from the React homepage itself, where the input box, the input text box at the top there is Markdown, and there's a client-side Markdown parser that's then being used to then format this output in the second div that's there. The infamous to-do application, very, very basic. We can just keep on adding ourselves to-do items. Again, nothing particularly exciting there, but these are all just your canonical React examples that come from the React homepage. So this is an example called Gopherize Me, and I have to credit Ashley McNamara and Matt Ryer for creating this. They actually created theirs as a JavaScript-based application, not React-based. And so I've created a Go and React-based version. This is entirely front-end logic here. There's no back-end to it, but you can sort of imagine how it might be connected to a back-end. So let's just have a quick play around here. The left-hand side is essentially a preview of the Gopher that we're trying to create. Very nice. We can shuffle. We can create all sorts of different styles of Gopher here. And the right-hand side, there's clearly some sort of shared state here because you can see the current body is brown here, and we can then just click around here. We can just customize our Gopher however we like. So you can sort of imagine how, given everybody here has used React, how actually you might structure where the state would sit, what the props would be, etc. So this is perhaps just a bit more of a fun example. But this is not a complex React application by any stretch of the imagination here. This example here credited to TJ Holloway, who some people in the room may be aware of from the Express framework. An absolutely amazing designer as well. And so with his kind permission, I've cribbed and borrowed this example here. Again, it's a rewrite in Go and React of a project that he has for testing website latency or URL latencies. So this is kind of a faked version here because I actually just have it creating some random timing values instead of actually testing a URL where it would make a call to a backend service where it can actually test the latency for you. I'm just faking some values here. So again, the idea behind this is just that, yes, you can make backend calls, but fundamentally your interactivity can just be HTML and CSS based, which this one is here. There's no interactivity other than just clicking on the button. Start with. So with all of this, as everybody here is aware, we've got JavaScript as being the language, for now at least, that allows us to create this interactivity, i.e. sort of in response to a click event or a keyboard press. JavaScript is the language that allows us to actually respond to those events and provide the interactivity. But there is a wider option space than just writing in JavaScript, as again, everybody here is probably aware. So let's just quickly scan down the list here. CoffeeScript, yes, okay, you could write in CoffeeScript. TypeScript, a very popular one, because it's introducing a level of type safety in there. So a compile step sort of pre the application being distributed to the front end. ClojureScript, the list goes on. And any other language that might actually compile to JavaScript, or in the future, ASM.js or WebAssembly. But sort of ignoring WebAssembly for now, or indeed ASM.js, I'm just going to focus on JavaScript is essentially the target today. And just briefly talk a bit about TypeScript, because this is really the reason why I created this project that I've been working on. So this is a brief and a very incomplete analysis of TypeScript. It's based on around 2.5 years of experience we have with a medium-sized TypeScript application, I would say. TypeScript is, how many people have used TypeScript? Again, just a quick, so again, that's a sort of roughly similar number. So TypeScript is quite a large language in terms of its specification. In fact, the specification is extremely long. Our experience with that was that there's quite a lot more edge cases when actually using the language itself. And not only that, it's then quite a bit harder to write tools that work with the language. So for example, in code generation, whatever it may be, if you're having to parse some TypeScript code, you have to handle quite a lot of cases within your parser and whatever you're trying to do with the abstract syntax tree that results. There are some quite painful hangovers from JavaScript as well. The plus operator being perhaps the canonical example of how, yes, you have type safety within the TypeScript world, but it can and is abused, if you like, within the TypeScript world to just, you can add anything you like. And yes, the result is, well, you have to then go and read the specification. And there's too much guesswork involved, to my mind, with whether there's that sort of hangover. There's a lot of compiler options as well to sort of satisfy people coming from different backgrounds. So if you're starting out with a TypeScript application, which compiler options should you use? Okay, again, it's not very clear from the get-go how you should be starting. The compiler is single-threaded as well, which leads to slightly longer compile times. Now, there were some very good optimizations released about 3 or 4 months ago that helped with this, but we had compile times that were around 10 to 12 seconds for just a medium-sized application. So that makes your development cycle quite long. If you're making a change, you then want to compile and then test the result. If you've got 12 to 10 to 12 seconds each time you're doing that, that starts to get very painful if you multiply it by however many developers you might be, who may be working on the project at the same time. So that low development velocity doesn't lead to great developer experience, to my mind. They have made, I will say that they have made some improvements, which we have noticed because our main application is actually still in TypeScript for now. But this was largely the reason why I started looking at, okay, hang on a second, we're using Go on the back end, where it's lightning quick in terms of its compilation. It's a much smaller language. We're writing lots of language tools. Hang on, can we actually start using Go in the front end? So this is why we asked the question, is there another way to do this? We ultimately have to target JavaScript for now. As I said, I'm ignoring WebAssembly. So we have to go, what we have to end up with is JavaScript. So what can we use as a language, as a starting point? So this is where the Gopher comes in. As I said, it's the mascot for the language. And as a language, Go addresses, or doesn't suffer, if you like, from a lot of those points that I made about TypeScript as a language. So a very quick rundown of what Go is, for those who haven't used it before. It's a compiled language. It has sort of native support at a language level for concurrency, i.e. allowing you to effectively have more than one thread of execution at the same time. Like JavaScript, it's garbage collected, but unlike JavaScript, it's statically typed as well. So i.e. at compile time, you have to have annotated all of your code with types, and those types, your program then has to actually compile, i.e. the types have to be compatible. It was developed at Google to address problems of large-scale development, i.e. they had loads of C++ at Google. That just became a nightmare to manage. Build times were very long, et cetera, et cetera. So it was a very specific engineering solution to the very specific problems that Google had, but that they actually thought, okay, the solution to this is going to be generally useful to other people as well. In contrast to TypeScript, it's a very small language, so you can go and look at the language spec and read it in not much time at all and actually understand it as well, because the language is much simpler. There are far, far, far fewer edge cases, therefore, because the spec is much smaller. There's an extensive, well-defined standard library. Now, this does not exist in the JavaScript world. Instead, you have to be installing packages in order to get function X or solution Y. The Go standard library gives you a huge amount to start with, and in fact, you could, dare I say, sort of write almost anything with just the standard library itself. Of course, you reinvent a number of wheels by doing so, but the standard library is an extremely good starting point. It's a very easy to read language. It's easy to document as well, so when you're writing code, you can easily document your code, and instantly using the go doc command, you can then see the results of that in a nicely formatted HTML output. There's absolutely no rocket science about it, but if the language is easy to read, plus it's easy to document as well, it encourages people, as Claudia was saying, to actually document things and make it more easy for other people to understand. There are fantastic language tools. You can automatically format your code. Again, that's not unique to Go, but there is just one tool that does that in the Go world. It's called Gopher, and therefore everybody's code formats in exactly the same way. There's no options. That's it. But that actually makes it much easier to read as well, because Claudia made the point there as well. That's effectively an idiom. If you then can look at some code, it will always be formatted in the same way. It's much easier to read. As I said, it's because the language is much smaller, it's very much easier to write your own language tools. For example, if you want to write a code generator, it's very easy to parse some Go code that you have and then do some code generation off the back of that. The packages that are in the standard library make that extremely easy to do and easy to understand as well. Very fast to compile and run, which is why it's a language that's favored on the back end. So Docker, which almost everybody will have used or be familiar with, is entirely written in Go. Kubernetes, a number of these sort of systems-based tools, frameworks, whatever, are written in Go because it compiles to native code, which is extremely fast, optimized for your processor architecture. So it's found a lot of favor on the back end for that reason. Hopefully that's just about visible. This is a very simple example, your canonical Hello World application here. Go's code is organized in terms of packages, and the package main is a special package that allows you to define an entry point into your program. And func main, much like C code, is the entry point itself. So what we can do is we can just run this here, and it's not going to surprise anybody what we actually see as a result there. But you can see, very simple, func, this is the definition of the function that is main here. We've imported a package here, funct, which is going to allow us to do some formatting. In this situation, formatting, func package allows us to just print a line, and that prints it to standard out. Very, very basic. And the Gopher gives a really good sort of introduction to the language itself, so encourage everybody to take a look at that. This is a slightly more interesting example because, as I said, Go has, as part of the language itself, effectively, if I can call it, native support for concurrency, and has the Go keyword, which you can just see within the main func here, that allows you to concurrently execute this function here, concurrent to what then follows, which is also calling the say function here as well. So you can sort of guess by just looking at it, if I tell you this is going to concurrently execute say world with say hello here, what's actually going to happen? We're going to get some sort of interleaving of hello and world. And as you can see from the loop above here, which again looks quite C-like, it's just a simple for loop. 5 times, it's going to sleep for 100 milliseconds and then print whatever the argument was to that function. So there we go. Nothing particularly exciting about that. But again, it sort of gives you a bit of a flavor for how simple the language is, hopefully, by just there we did something concurrently without needing to talk about a thread library or anything like that. Just as a primitive within the language, you have concurrency. And the Gopher itself goes on to talk about other primitives within the language that are channels. And channels are the main way in which you communicate between concurrent parts of an application. But we won't look at that today. So there are other aspects of Go that I've got listed here that are covered entirely in the Go tour, but I'm not really focusing on a language. It's not a language tutorial today. This is just to give you a bit of a flavor for the language, but predominantly how simple it is as well, which, as I said, is the reason for why I chose to actually try and wrap the React library with the Go programming language. So, but there's a bit of a problem because we can't run Go within the browser. JavaScript is, and again, I'm sort of ignoring WebAssembly, the one language that you can run within a browser-based environment. That's the only virtual machine that a browser has, and that's to run JavaScript code. So if we have some Go code, how do we actually get JavaScript out the other end? Well, this is where a fantastic tool called Gopher.js comes in. You can sort of tell where the name has come from here. It's an outstanding piece of work by Ricard Musiol and the Gopher.js team. And it is a compiler / transpiler, if you want to get pedantic about definitions, that takes your Go code and spits out JavaScript, with the principal target being the browser. So if I've written some Go code, I can then take that Go package and compile it using Gopher.js, and it will generate for me a JavaScript file that effectively represents that compiled result. So this is effectively exactly what we're after in this situation. We've got our Go code. We want to be able to write Go code and then run it within the browser. So this is where Gopher.js fits in. So what does Gopher.js support? Gopher.js, as I said, is this compiler transpiler. It supports every feature within the language, even though it's a sort of very small language spec. Almost the entire standard library. So the standard library includes things like NetHTTP that allows you to make HTTP calls, encoding JSON to deal with anything that maybe you need to encode to JSON or decode from JSON, encoding CSV. You can sort of guess where this is going. And the entire Go standard library is extremely well documented as well. The performance is pretty good in most cases. It's nowhere near as optimized as some other compilers and transpilers out there, but it's pretty good. And there is an HTML5 game engine example that's written using Gopher.js. So that gives you some idea that actually the JavaScript that it generates is pretty performant as well. Source map support, a DOM package for interacting with the DOM, a JavaScript interoperability package. So if you have an existing JavaScript library, i.e. React, the ability to interact with that. And that therefore gives rise to the final bullet point there, which is bindings. You can then write bindings packages that effectively wrap an existing JavaScript library and allow other people to then write pure Go against your bindings and have that compiled to JavaScript at the end of the day. So that's exactly where the React side of things comes in. React needs absolutely no introduction to everybody in here, but myitcv.io/react is a Go package that is those bindings, the wrapper, if you like, around the React package. So that then just allows anybody else to write Go code using this package, use Gopher.js to then compile the result and have that result then run within the browser. So as I said, it's a set of Gopher.js bindings for Facebook's React. It wraps the JavaScript library that Facebook distributes and presents this Go interface. And I use interface in quotes there because an interface is actually a thing within the Go language. So by interface, I mean just how one interacts with something. The package also gives you ReactGen, which is a tool much like Create React App or any sort of other initialization tool for getting you started, but it also acts as a code generator to help you along the way as well, to save you having to write a whole load of boilerplate code when we declare our components, props, and state. So let's get straight into it by therefore looking at how we create an interactive front-end app. So I've skipped over a whole load of prerequisites, setup, etc. This is all covered in blog posts and on the wiki that I've got. Feel free to ping me with any questions on sort of getting started, but it would be incredibly boring to actually go through that setup today, so I have skipped it. And so here, we're just creating ourselves. You can sort of ignore the Go path environment variable there. Again, that's covered in the Go tour quite well. We're just creating ourselves a directory, and then within that directory, we're calling ReactGen with an init flag here, because I just want to create myself a nice-looking Bootstrap-based React example. Okay? So what does this actually look like? Again, this is effectively a live example within the presentation. Very, very basic HTML-based app that results here with just a heading and a paragraph of text. Not particularly exciting. So in terms of files, what did ReactGen generate? Well, unsurprisingly, there's an HTML file that effectively represents the entry point for our application, right? Because it's that HTML file that gets loaded within the browser. That bootstraps the loading of a JavaScript file, which bootstraps React, etc. Right? But you can see there's no JavaScript files obviously been generated here. That's where Gopher.js comes into it, but it has generated 3 Go files there. So let's just take a look at each of these files very, very briefly. This isn't going to surprise anybody in the room here. HTML, which has a div, which is effectively going to represent the root of our React application. Nothing particularly exciting there. The script that gets loaded at the bottom, however, is the result of the Gopher.js compilation. So it takes those Go files up to a single JavaScript file, which gets loaded at the end of the page. Okay, so then that is the bootstrap of our application, if you like. Main.go, like before, this, as I said, the main package is a special one because it represents the entry point into our program, or our web application in this situation. You can sort of ignore all the bit at the top there and focus on the, if I can just highlight this bit down at the bottom here, hopefully, the actual main itself down at the bottom here, where again, this looks kind of familiar if you've written React apps before, where we're using the DOM package here, specifically the document, a reference to the document that is the page itself, to get an element by ID, i.e. the div that we declared on the previous page, and then render within that div a particular React component. So that sort of said, it looks very functional here in the way that we're actually creating an instance of the what looks like a component called app there. So let's take a look at the definition of that component. So this is where there's a bit of, there's obviously a marked difference here between the way that you would declare a component in JavaScript and in Go. So I'll try and provide that contrast as we go through the next couple of slides here. So if you're creating a new component in JavaScript, that's declaring a class that extends ReactComponent, or TypeScript, the equivalent thereof, right? And then you're declaring a method within the class that is the render methods, the get initial state, whatever it may be, component will mount, all of these things, right? So we're going to have something that looks quite similar to that here, but we don't have classes within Go. There's no such concept. Instead, we have type declarations, and at the top here, you can see this is where we're actually declaring our app component. And we'll come on to the naming conventions in a second. But the best thing to do is to look at the bottom of the slide here where you can see the render method, and that kind of looks a bit more familiar at that point, right? We're declaring a render method which is declared on the app def type. So this is saying, right, fine, for this particular component, the app component, this is its render method, and you can see it returns a React element, which in sort of the TypeScript equivalent is it returning a JSX element. And unsurprisingly, given the page we saw earlier on, it's rendering a div that contains an H1 and a P, i.e. exactly what we saw on the previous pages. But we also had a what looked like potentially a code-generated file that was generated for us as well, the gen underscore prefix and the underscore ReactGen suffix. This file exists to save you writing a whole load of boilerplate code. Because Go is a fully typed language, you actually need to write quite a lot of boilerplate code effectively to write components in a React way. And so ReactGen helps you do that. It creates those type-safe methods, it says there, and yeah, saves you a whole load of what would otherwise be quite monotonous code that you don't have to do in the JavaScript or the TypeScript world, because those two languages are quite a bit more expressive. So let's just take a quick detour into the world of Go generators. As I said, it's a code generation tool. And what it does is it starts from Go code generation, and goes to something. In this situation, we're going from 2 Go files here, and we're creating a third Go file. So what this ReactGen tool is going to do is it's going to try and find our component declarations, and then create all this boilerplate code for us, and just spit out these files as we're working. So if you have a file watcher running, for example, you can just be coding away there, declaring, okay, I've got a component here, save the file, the code generator will run and generate a whole load of boilerplate code for you. So that's where this code generation step comes in. And the idea behind, again, writing these sort of language tools is that you write such a tool in order to write less code yourself. So that's sort of the motto behind them. So let's go back to our React components here and look at how we would write our own React component, a very simple one. As I said, there's a naming convention that's used here where we have a def suffix, to the name of the component. So here we're going to create a component called foobar. Okay, so what we do is we have a type declaration here that is foobar def, and this structure here where it is of types, it is a struct type that has a particular embedded type there, that's the only signature that's actually required in order for the ReactGen code generator to see, okay, this is a component you're trying to declare. So if you save this file at this point, it would spit out a whole load of generated code for you. Let's say we also want to add our component to also declare some props. Unsurprisingly, that has a prop suffix. So here, we define another type, declare another type, foobar props. It's a struct type, and our props are going to be very simple. It's just going to have a name field, which is of type string. You can sort of guess, therefore, where, if we want to declare state, how state types are declared as well. Foobar state, struct type, again, and just a single field in this situation called age. So this is a fairly well-rehearsed example. You can sort of guess what this component might actually do. So ReactGen, with us having saved those, let's just assume we put all of those 3 type declarations in one file and save it, it's going to spit out a whole load of methods for us to help. So it's declared here 3 methods on our foobar component, remembering that the foobar def type is the component itself. It's got a props method, which gives us the type, the foobar props back, the state method, and the set state method. So again, very familiar, and sort of there is the equivalent, obviously, within the TypeScript and JavaScript world. So now let's get really concrete by defining our render method. And so in this situation here, you can see that within the render method, what we first of all do is get the name, the current name and age based on the props and the state. And you can see we're using those code-generated props and state methods there. We're again using the fumped package in order to format a string using that name and age. And then you can see we're simply returning from this a div that has a paragraph, which contains that formatted string, and then beneath it a button which has got a click handler. And the click handler, all we're going to do is bump the age, i.e. increment the age by 1 here. Okay? So let's just take a quick look at the click handler itself and how that's implemented. Again, a lot of this stuff is based around type declarations in Go. which is where, so I don't want to say it's the equivalent of class declarations, but because they're very different concepts, but you can sort of imagine them as being quite similar. And so here we actually declare our click handler as a separate type here, and you can see we're declaring a method on click on that new type, and that's this type, the age click type here, then implements the on click interface. So that means we can then use this type as a click handler. So very basically, it's just wrapping the foobar def component. You can see it gets the state, bumps the age on the state, and then sets the state back. So nothing particularly exciting there. So in much the same way that we have declared the component, we actually need to create an instance of this component if we actually want to use it. And that's where we just write ourselves a very simple function, foobar here, and we'll see how that function is used in a second. And obviously, if you want to create an instance of a component, you need to pass it in some props. And so we declare that that has a single argument that is of type foobar props. So now let's extend the app component that we had code generated for us with ReactGen to actually include an instance of the foobar component here. So you can see previously that this is exactly the same app.def render method we had before with the heading 1 and the paragraph. And now all we're doing, again, just using this sort of fairly familiar pattern of composition, is creating an instance of the foobar component by calling that constructor function, passing in an instance of the props. In this situation, we're just passing in the name Peter. So as Claudia said earlier on, React, it's very functional, very compositional in the way it works, and that's exactly the same with the Go wrapper that we have here. So here is, if I can just find the mouse, here is our extended application where it's using the foobar components. Unsurprisingly, it's just bumping the age each time, and then setting state in exactly the way that you would just write any React application that wanted that state local to that component. So if we were to look at this within the browser, React Dev Tools work in exactly the same way, because don't forget, all we're doing is generating JavaScript here. So React tools that work with a JavaScript-based React app work equally well with a Go React-based application, because again, it's still just generating JavaScript. So you can see here the component hierarchy from the page that we were just looking at, where there's the outer component, there's the app component that has the H1, the P, and then the nested foobar component within it. So that's a useful thing to have, is being able to reuse existing tooling that exists for regular JavaScript React applications. So let's just go back to the example of Gopherize Me from earlier on, and just talk a bit about the structure of this application, because it's kind of a useful example. So as we said, we've got this preview area on the left-hand side where we've got our Gopher, which is clearly being told, okay, what eyes should you use, what bodies should you use. You've got a couple of buttons, shuffle, reset up the top here, which must have some sort of handlers associated with them. And these sections down the right-hand side, panels down the right-hand side here that allow you to configure what the Gopher looks like. So let's just put some glasses on, for example. So what does this component look like in terms of the component structure? There's going to be no real surprises here, but we can look at it in terms now of the actual types that we would have to declare in the Go world. So this is sort of, you can think about how you would do this in JavaScript, TypeScript, whatever language you use for React, but this is the types that are then used as far as state and props are concerned for the components in the Go world. So the outer component is the one that holds the configuration of the current Gopher, i.e. what does the current Gopher look like. Let's just also assume there's some configuration that we have made available to us that says, well, here is the list of eyes, here is the list of bodies, and these are the images, etc., that go with those various options. So that's the config option in this situation. The preview panel on the left-hand side just needs to be told, well, what does the current Gopher look like? So its props type there, as you can see, receives a Gopher type as part of its props. The chooser bit, which is on the right-hand side, well, that also needs to know what the current Gopher is. It also needs to know what the config is, because of course it's the thing that contains all those panels down the right-hand side. And we also need to provide some sort of way of updating what the current Gopher looks like, because let's not forget that state is maintained in the outer components. So you can see the props for the chooser component look roughly like that. The chooser also has some state, of course, which is, let's just flick back one slide here, which of these panels is actually open. Right? So that state is something that is local to the chooser component on the right-hand side there. So then within the chooser component, there are all those panels that you saw, and I won't go through all the details here, but you can therefore sort of see how the props for the panel then come about in this situation. Oops. So the one thing we haven't talked much about here is we've got this sort of config thing that I've waved my hands at and said, well, this is where you get the list of eyes, the list of bodies, etc. Where does that actually come from? Well, this is where we can just briefly talk about, just sort of before we wrap up, backends, because of course we've only talked about front-end logic here and the JavaScript, the results from compiling from Go to JavaScript. The beauty of having the standard library, well, hang on, let's just summarize where we are first of all. So as I said, we've written an interactive front-end app in Go. It's very, very basic, but we've used React, and you can sort of see how to declare the components, the props, and the state, and sort of relate that back to how you would do it in JavaScript, TypeScript, whatever. So it's exactly the same concepts as Claudia said. It's sort of reusing that idiom of component, props, and state. There's no change as far as that's concerned. myitcv.io React is the package that, along with ReactGen, that allows you to do that. It's effectively the wrapper around the JavaScript library. We can sort of see how code generation fits in and why code generation is useful. It's just saving us having to write a whole load of boilerplate code, which is only a good thing. But we don't have any data in our application. I sort of said that this config has come from somewhere. I haven't sort of said where. So this is obviously where you would get that configuration from a backend, for example. So what is that option space for backends? Well, no backend at all. You could hardwire into your front-end app, well, this is the list of faces, this is the list of bodies, etc., with hardwired links to this is where you get this image from, etc. Okay, you could do that. Some sort of JSON REST-based API. You could use Google's protobuf over HTTP 1.1, gRPC, which is an RPC-based framework over HTTP 2. The list goes on and on. But the beauty is that you can use any sort of backend because the Go standard library allows you to, well, you've got the entire power of the standard library. So if you want to connect to a JSON-based backend, very easy, over HTTP 1 or HTTP 2, you've got NetHTTP in order to actually be connecting to that backend, and you've got the JSON package to do the encoding and the decoding for you. Much the same way with protobuf as well. If you wanted to use that, far more efficient than JSON, but all of this is available to you within the Go standard library, i.e. you don't have to install any other packages unless that's actually sort of more convenient for you. So there's a really good example that I've linked from this slide here to a gRPC-based backend, and Johan Brandhorst has done some fantastic work that connects a Go.js front end to just a regular Go backend. And of course, the benefit you have there is that you have Go code that can be shared between the back end and the front end, which is obviously another really nice benefit of having the same language on the front end and the back end. So I think that's pretty much it. That was a bit of a lightning tour through things. But as I said, just sort of going back to this, to the recap slide here, you can write interactive front-end apps in Go and using the Gopher.js compiler with a wrapper around the React library. That sort of reuses all the same idioms that exist in the standard React JavaScript library, but you just have to get used to the fact that, okay, this is going to be in a different language, the tooling is slightly different, and therefore the development approach is slightly different. So that's it. There's a whole load of links, etc., that I'll post. Just sort of getting started. Link to the Go tour and the Gopher.js Slack channel where there's all sorts of people who are available to help and happy to help with anybody who wants to start writing some Go and have that run within the browser. So I think that's probably it, unless there's anybody has any questions. Yeah?
Is there any JSX support?
That's a really good question. So no, there isn't. So the Go as a language is, let me just go back to this example here, for example, right? Because this is typically where you would expect to see JSX. So no, there isn't, because this is just compiling, just taking Go and compiling that to JavaScript. So Go has not been extended as a language. In fact, it's kept extremely tight. So for there to be the equivalent of JSX, you would essentially be looking to extend or sort of, I don't want to say fork the language, but effectively to say, right, I'm going to add this syntax in to give JSX-like support. So I have some sort of fake JSX support where using a string constant, that string constant contains HTML, it parses the HTML and spits out the equivalent as if you'd written that as Go code. But that's sort of fake because, of course, true JSX, you can actually, it's not a constant and you can have variables interpolated as part of the JSX. So you would have to fork, and as you say, create a preprocessor or an additional compiler that takes and understands that JSX syntax. You could effectively rewrite that into Go and then just compile that on once more. But no, there's not JSX support other than, as I said, that sort of fake constant string-based JSX, which is by definition quite limited. Cool.